Good morning. I'm Augusto Neiva from the University of São Paulo, Brazil, and I'm presenting a paper about the comparison of class hours in six metallurgical engineering courses. Uh, our school is very old. Our course is very old too. We think we are good. We think the students learn. But if you ask if they can apply, model, correlate, and prove verbs like that, we are not so sure they can do this every time. Can we improve this process? Well, we have good subjects, basic, engineering, science, applied, main subjects. We have good classes and some active learning. But the question is the skills. We must do something else to develop these skills. So we decided to modify the course in order to develop skills following the government guidelines. Specifically about the specific skills, verbs like model, design, correlate, select, and should appear. And the question is, does content still matter? We've prepared a list, a proposal list about specific skills. All of them included technical and scientific questions. For instance, the first one included the raw materials and semi-processed engineering materials. The second, composition, structure, processing properties, performance. The third, the behavioral materials. And finally, optimizing production, improving product performance. So, attitude is important and contents are also important. So one of the steps is to think about the contents. Are they okay? Are they logically structured? I mean, for instance, vertical and horizontal integrations. Is there something new or different outside? So our objective here is to compare our curricular structure to those of other courses in Brazil and outside by acquiring data of their curricular structures, classifying the subjects into three levels of categories. A very broad one, for instance, fundamental versus applied. An intermediate one groups, for instance, math versus physics, and a more detailed level with the terms, for instance, calculus versus geometry. And then determining the total class hours of each category in the six courses. We've made a good literature review, for instance, about curricula, connections between the contents, and also many papers describing and comparing curricula. The criteria for that were very different in the papers. For instance, simply listing subjects and comparing them, or listing topics or themes, or thematic models, broad fields of knowledge, clusters, and the courses, the, the most studied courses were civil engineering, mechanical engineering, chemical engineering, and electrical engineering. Metallurgical engineering, we found a paper which compares broadfield as fundamental and applied as described in the sites of the courses. It was made also in our department. Our methodology was the following. We first went to the internet and compared and got data from Colorado School in USA, USTB in Beijing, China, and from four Brazilian courses. Then we created a list of 96 themes, and each subject was assigned to one or more of them. It was based on the titles of the subjects, uh, directly through the identification of keywords or indirectly through the conceptual identification of the subject content. For instance, a term manufacturer could be found by the keywords forging or welding and several other. It's important keywords are not classifications, they are tools. For instance, two keywords records here for the keyword physics or física in Portuguese. We looked for phys, and we used the operator not to avoid physiologia, chemistry, and so on. Why avoid the chemistry? Because we wanted physics and chemistry together to lead to physical chemistry. So we could find physics, physical, physica, physica, physicus, physicus, physicas, physicas, a lot of words could find by that. We got then the terms associated to the subjects, and we validated this process individually by our team. So the selection could be validated or not. Then we listed the class hours for each subject. For mandatory subjects, the credits were fully considered. For restricted elective subjects, only a fraction. It was inversely proportional to the number of alternative subjects. Finally, we grouped the themes in groups and families, those separate levels. Uh, 10 families, for instance, basic and specific. 32 groups, for instance, maths and physics. 96 themes, for instance, calculus and geometry. Let's see the basic subjects. We have here 6 groups: physics, physical chemistry, maths, thermal, mechanics, chemistry. For physics, we have 5 themes inside. We have here 4 families like that, and here 6 families with just one group inside with the same name of the family. In short, we had the subjects, the keywords, first routine, list of themes. We validated or not each one or modified it. And then we linked this to the list of class hours, the tree structure. So we got total class hours for themes, groups, and families. I'm showing I'm showing now some results. Brazilian courses were 5 years, and Colorado and Beijing 4 years. Even dividing these larger values by 5 and those by 4, Brazilian courses had more hours, year hours, than the other. Here, 800, 500, 600. It was not new for us. We knew previously that more or less. Let's now compare the 3 levels of specificity. The more broad one, families, we see that basic and specific are the more important, of course, but for some courses, basic was more important, for other specific were more important. If we compare uh, the most basic course is Colorado, the less basic course is our. In the intermediate level, the groups, we have an example here. For the family-specific subjects, we see that materials characteristics and selection was very important. Physics and chemistry of materials also for other courses. Processes A and B, also important for Brazilian courses, not important for process A, not important for Colorado and Beijing. Process B, not important for Colorado, not so important for Colorado. In the other family, basic, physics is important for every course except the Minas Gerais, and it was replaced by physical chemistry and chemistry and math for all. Um, Now we have an example of the more specific level. For the group mathematics, calculus was important for everyone except for Rio Grande do Sul, and it was there replaced by geometry. The same method was used for another very simple classification of subjects. You wanted to know the comparison about theoretical classes and laboratory classes. Uh, our previous analysis was based on content, not in the method. So we could not do that there. So we made everything again. And we see that Colorado and Beijing had around 10% or 8%, while Brazilian courses, except the Minas Gerais, around 3 or 4. Some conclusions. This classification into 3 levels and the accounting of class hours allowed different kind of description and comparison to be made. The method adopted to associate the subjects by the use of keywords proved to be practical and transparent, avoiding involuntary changes of criteria. It was flexible, allowing different classification approach to be used. The process for calculation of restricted elective subjects was necessary and very useful. The results allow some very general tendencies and now specific trends to be observed, and these facts may be taken into consideration for the analysis and modification of the curricula. Thank you.